Good morning, everyone. Today we're going to continue our discussion of simple and log returns. By way of review, we learned how to uh, compute for the simple returns of a single asset, and we learned that that formula is simply equal to the return of a single asset, single point in time is P sub t over P sub t minus 1, or it can be expressed in this way. Then we learned that to get the cumulative returns for multi-period, so we just get the product, 1 plus R1, R2, R3, etc., where R1 refers to the simple period for its respective, simple return for each respective period. Okay, so we discussed this at length last time, and then we learned how to get the log returns. And we said that log returns are preferred in finance. When we're studying returns, log returns are preferred because of several reasons. Number one, it is additive. To get the cumulative returns, you just add the the respective log returns, and then also because of its distribution, log returns can go from negative infinity up to infinity. Okay, so it's more it has balance at zero, unlike a simple returns where the minimum is at negative 100% and the maximum is at infinity. So the log returns is preferred in financial analysis. And when you get the cumulative returns for log returns, you just add. Okay, it's additive. Okay, and we had several examples of this last time. And we also learned to convert your simple returns into log returns. You just use this formula. The simple returns is simply equal to the exponential of your log returns minus 1. And then we also learned that this can be expressed as your log returns. Okay, let me just write that. Okay, did I write it here? No, we can write it here using LaTeX. Let's just use that class. So Control C, Control V. And then here you have, I'm not sure if we wrote this last time, formula to convert log returns to simple returns. Okay, so we discussed this last time, I think. Okay, but just in case, no. So you have this formula, R sub t. Let me just expand this. Okay, I'll write here in the blank. Okay, from the formula, R sub t is equal to E to the RT minus 1. Okay. I'm sorry. Wait. Got confused with the formula. It's log here. And then, I'm right. Sorry. Okay. Baliktad pala yung log yung sa log to simple returns. All right. R sub t, which is the return, simple return is equal to your log return minus 1. Then in order to compute for R sub t, given your big R sub t, your simple returns, we have to, we're transposing 1 on the other side. So we have 1 plus RT here, and it's equal to E to the RT, R sub t. Okay? And in order to cancel out epsilon exponential, we said that we get the log. So getting the log of this results into log of 1 plus RT and that's equal to log of exponential RT is equal to RT, R sub T, because log and exponential are inverse functions, so they will cancel out each other. Okay, so this is the formula, class. Log returns is equal to the log of 1 plus R sub T. Okay, so let's do an example where we simulate our data. Okay, let's load first tidyverse. We're going to need tidyverse is a package that comes with a family of other packages. So if you load tidyverse, if you haven't installed it, class, please install it. You know what to do. Install that packages and then library. Okay, let me do it here. Install that packages and then tidyverse. Okay. If you load up, sorry, I need to put install the packages. What's wrong? Error in updating loaded. Updating. Oh, I was loading some other packages before. Okay, again, Control Enter. One or more, starting R. Okay, never mind, class. It's already installed anyway, in my case. So I'll just go here, packages, and then tidyverse. I'll just check this. Okay, so you notice that when I load this, there are other packages that come with it. Dplyr, forecats. Okay, so this is for categorical variables. ggplot2, lubridate, a very powerful package for time and dates. Per, readr, stringr, table, tidyr. So these are other packages. These are the other packages that come preloaded with tidyverse. When you load tidyverse, these packages are also loaded with it. So once you load tidyverse, you don't need to load ggplot2, lubridate, dplyr, etc. because it comes already preloaded. So this means in conflicts class, no? This means that when you use the filter function, okay, there's a filter function that comes from dplyr, and there's another one that comes from stats. Stats is a package that's preloaded. Preloaded with R, which means that when you open R Studio, okay, stats will already be preloaded. In fact, if you check here, class, type stats in the packages, and then see it, you'll notice that it's checked. Okay, it's already checked, even if you haven't required it, even if you haven't used library, because it will always be preloaded. Okay. All right. So have you loaded tidyverse already, class? Make sure that it's already loaded. Kindly chat in the chat box, please. Okay, good. Thank you. Okay. I did not provide you all the codes. Okay, for example, for this one, I did not provide this to you. So I want you to create this object prices. Okay, and it contains these values 100, 102, 103, 104. So this is similar to the example we did last time, but this time we're going to use R in order to generate this vector, okay, vector of values called prices. Okay, so kindly do that. And then let's create another object called dates. And then it will, the function paste 0 combines two, either two characters or a character and a number. So here, date, I'm combining day and then I'm leaving this one blank in order to append or to fix or to attach this one. From 1 up to the length of prices. Okay, so let's run this class. Okay. And please tell me if you're able to run already this one. And you will have two objects, prices and dates. I'll wait for you to finish that and kindly chat yes, please, if you're done with that. So this is for 12 days. Okay, for the others. Okay, thank you. Okay, I hope you're done, class. So if I run this, okay, if you check our environment, you'll notice that in my case, sorry, I have so many items here. Where do you find prices? Is it under data or is it under values? You'll find that prices will be under values. Why? Because it is just a vector. It's not a data frame. So that's why, class, I hope you have watched. Again, let me remind you to please watch the videos on data and data structures. You'll see that prices, just like day, is it dates? Yeah, dates. Okay, dates is a character vector, and prices is a numerical vector. So that's why they're found under, andito sila sa values and not in data. Okay? So ito yung prices natin, di ba? If I print prices here, prices, you can see that it's the list of the values that we created, and dates. It will be day 1, day 2. So it combines day and then the number from 1 up to the length of prices. Prices has 12 elements, 1, 2, 3, 4, etc. 12. So this is the 11th. You can see here 11 and then 12. So it creates day 1 up to day 12. If I remove this class and then run this and then run again dates, print the dates. Okay, notice now that there's no space here. Okay, day and then immediately 1. Okay, Anyway, I'll just use the other one, the one with the space. Okay, now what we can do is we can combine prices and dates and create a data frame or a special table, which we call a table. A table is a special data frame. So we create this object called price data. Okay, price data, and we use the function table, or we can use as.data.frame. It's the same. And then we write the column name date, and what will contain date? It will be the dates, and then price is equal to the prices. These are vectors, right? So these are recognized. This is the column name, date, and then the price. And then we print, let's see, what will be inside the price data. Okay, once again, I'll give you a few seconds to write the code. So we're creating a data frame. A data frame is supposed to be a rectangular array containing rows and columns. And there are other special features of a data frame, but I'll not discuss it here, class. I hope that you have watched the video. Okay, let me run this and print. Okay, so you can see here the data frame that we created. Date, and then price. And then the object that we created, this one, price data, you notice it's under data, price data. Price data is here, class. It's not under values. Price data is under data because it's a data frame. So when you're creating a data frame, a table, it will be under, you'll find it under data. But when you're creating only a vector, then you'll find it under values. Okay, and if I print this price data, if I click this one, it will show here. There you go. So there are 12 observations because we have 12 prices, and 2 columns. We have 2 variables, date and then price. Okay, so let me. Are you able to follow so far, class? Kindly please chat in the chat box. Any questions? Everything clear so far about the data frame that we created, the table that we created? This one? Okay, thank you so much. How about the others, please? Clear so far? Okay. All right. So let's now have a review of what we discussed about computing for returns. So let's first compute for the simple returns, and by review class, we know that the formula for returns is the price at time t over price at time t minus 1. So this should be there should be minus 1 here. Minus 1. Okay. Now let's take a look at this class, simple returns. We're going to use the vector prices. Okay, what's inside prices class? What do you have for prices here? Diba? This one. 100, 100, 200, 300, 4, right? That's what's inside prices. That's the element of prices. Okay. Now, if you say prices -1, what does that mean? The square bracket here, okay, the square bracket class is used for subsetting. Okay. So when you say prices, and then you have a -1 here, it means that you're subsetting this object prices. -1 stands for do not include 1. -1 class. If I say prices then 1, it means get only the first element. Otherwise, if you see prices and then -1, it means get everything except for -1 for the first element. So this will be class, since this is prices, it will now be from 102 to 107, right? That will be prices -1. Okay, is that clear, class? If, for example, I type here prices, -1. Okay, take a look, class. There are only 11 elements here, and that it started with 102 and ended with 107. 102 up to 107, which means that it did not include the first element, 100. Okay, I hope that's clear, class. And then we have here, on the other hand, what about if I don't want to include 107? I'll include the first element, but I will not include the last element. We can make use of this function. You know, if you get the length of prices, it will give us how many elements are in this vector prices, and it's 12. So I'm going to use 12 and say that I want to subset prices, start with the first element, but exclude the last element. So this will be now the code for that. Okay. Prices, negative length of prices. Remember, length of prices will give us 12. The negative there, which will mean that it's negative of whatever this is. So it's -12, which means that I'm excluding the last element, 107. So if I copy this, class, Control C, and then Control V, let's see, Control Enter, and true enough, class, from 100 up to the 11th object, 11th element, 106. It did not include 107. Okay? All right, let me pause for a while and ask you if that's clear, class. Clear ba yung prices, -1, and then prices, negative length of prices? Because that's very important for us to understand, class, if we're going to compute for the simple returns. Is that clear? Okay, good. About the others, please. All right, thank you. Okay, so what happens now? This one is a vector. And what does it include? This one, 102, 103, 104, up to 107. This one is also a vector. Remember, a vector is an object that contains similar elements. This is a numerical vector because it contains all elements, all numbers. If it contains all characters, then it's also a character vector. If it's a mixture of number and character, then it's not a vector anymore. It could be a list. Okay, so what's happening here? We're asking R to use this vector, which is this one, and then divide it by this vector. Okay, now can it be divided? Yes, because they both have the same elements. So if I, for example, check what's the length of prices, -1. What's the length of this? It's 11. What's also the length of this? What's the length of prices? Negative length of prices. That's also 11. So we have the same number of elements. And so when we do this, we ask R to divide the prices, excluding the first element, which is this one, divided by the prices. Uh, prices -1. Okay, that's correct. Prices excluding the last element. Okay. What will happen? What will happen now is prices at -1, which is this one, right? It will be divided by this one. Okay, so 1:1 class. Since there are 11 elements, it will now divide it each of the elements of your vector. So 102 divided by 100. What's that class? What's 102 divided by 100? That's P sub t divided by P sub t minus 1, right? Because as far as 100 and 102 is concerned, 102 is your P sub t. 100 is your P sub t minus 1. Okay? So it's 102 divided by 100 and then minus 1. Okay, the next one will be 103 divided by 102 and then minus 1, which is exactly P sub t divided by P sub t minus 1 minus 1. All right, so this will now generate simple returns class. This is a vector. This is also a vector. A vector of 11 elements divided by a vector of 11 elements. The rule is when you're dividing or multiplying or adding vectors, it will add the corresponding elements so that it should have the same length. And then minus 1, which is the formula. So this is simply P sub t over P sub t minus 1 minus 1. The only difference is that we're using a vector. So you have several P sub t's. You have the same number of P sub t minus 1 and then minus 1. All right, so let's run this class. Let's run this. Control Enter. Okay, so you now have simple returns. And if I'm going to print this simple returns here, simple returns class. Control Enter. There you go. And we have 10, 11. We have 11 elements in your vector simple returns. Okay? That's to be expected because we have 11 elements in your prices -1 and 11 elements in your prices negative length of prices. Okay, so this is the P sub t, this is the P sub t minus 1, and then minus 1. So you get this. Just to check, class, just to check. So let's try 100, this one, 103. Control C, Control V. Or you can use just to prices. Okay. Prices class. These are your prices. Right? Ito, yung kompleto. I'm going to take price, the third one. Okay, the third one, 3. Okay, subsetting class. Divided by prices. And I'm going to get the second one. Minus 1. Okay, so that's actually the third element divided by the second element minus 1. And we're supposed to get this, negative 0.0098. Okay. There you go, class. It's supposed to be positive because the price increased from 103 to 102. Okay, let me pause for a while, class, and allow you to catch up. And once you're able to catch up, class, please chat yes, please. Okay, good. Thank you. I hope the others are able to follow. All right, so let's proceed, class. So we now have a vector called simple returns. Notice simple returns is under values class here. Simple returns, because it's just a vector of it's a numeric vector. Okay, can this become a data frame? Yes, of course, class. We can convert this into a data frame. So just make it as that data frame that will become a data frame. All right. And then let's now create a data frame here, class. Simple returns data frame. Again, we'll use table, or we can use as that data frame. Okay. So let's create now a variable called period. And then for period, same thing, paste 0. And then we'll start with day 2. Because, why day 2, class? Because for the returns, we have to use a period, right? So this is day 2 with day 1. So we'll just use day 2, or we can actually use period. Okay? You can change this into period, and then you can use 1. So period 1 will mean, the return at period 1 will mean day sub 2 divided by day sub 1 minus 1. So let's do that. Let's just use period 1 up to, so this should be, class, the length of prices is 12. Okay? So, mali ito, no? Dapat hindi 1 up to length of prices. Dapat length of prices and then minus 1. Let's see what happens. From 1 up to the length of prices, minus 1. We have to subtract 1. And then for simple return, we can use the simple returns object, which are 11 elements. Okay, so for your period variable, we have from 1 up to 11, and then your simple returns will be 11. Okay, so I'll give you a few seconds to write this. Okay, open table and then close. So I'll run this. Control Enter. Okay, I have an error here. Compatible. So mali yung ano ko dito, no? 1 up to, I have to put this in parentheses. Okay, let me see. Length of prices minus 1. Let me see this one. Mali pa rin. May something's wrong here, class. 1 up to, nag-error siya dito eh. 1 up to, if I put everything here, length of prices, okay, let me see this one. Error pa rin. Okay. Hindi ko ma-decipher tong length of prices. Let me check, class. Control C, Control V. Length of prices, minus 1. So 11 tama. Oh. So this should be correct. From 1 up to. 1 up to 11. Okay. 1 until, pero nag-error siya dito. Open, open. Kailangan ng close dito. Close. Close to. Yan. Okay. Ayaw niya. 1 up to 11. Okay, ganito na lang, class. Sorry about this. I'm going to change the, 1 up to simple returns na lang. Okay. So from 1 up to the length of simple returns, kasi simple returns is 11. I'm I don't know why I'm getting a syntax error dun sa when I use the length of prices. Ito. Anyway, to skirt the problem, so anong kulang dito? Open parenthesis, i-close natin si period. Okay? And then simple returns is equal to simple returns. Okay. I hope this is okay. Yan. Okay. Okay na. So print natin si simple returns. All right. As you can see here, class, period 1, period 2, period 3. Okay. So we just created a data frame, a table, consisting of ito na period and simple returns. And we called it simple returns DF. And simple returns DF will be under data yon. Simple returns to DF, no? If I click this, para i-view siya ito. Alright, so yan, class. Right, pause again, class. And I'd like to ask you if there are any questions or if everything is clear. Feedback, please, class. Okay, thank you. Let's wait for the others to give their feedback. Okay, a few more seconds. Any more confirmation, class? Are the others able to follow? I'm only getting a few reactions. Hello, how about the others? 1, 2, 3, 4, 5. 5 lang. 1, 2, 3, 4. Okay, thank you. All right. Please don't hesitate to ask questions if you have any. Okay, so we already have this object, this data frame, this table, period, and then simple returns. Okay, I think I prefer using the word period kasi pag day medyo confusing eh. Diba kasi there are 12 days, okay? And yet, when we compute for returns, we're not computing for the returns of a particular day, but rather period. So, because you're comparing two days in this case, because it's daily data. So it's either day 2 and day 1, day 3 and day 2, etc. So I just used period here. Okay, so now let's compute for the log returns. And we know that log returns is simply the log of the same thing, price at time t over price at time t minus 1. Okay, so let's use a different method, class. We could have used this one, okay? Okay, maybe let's what we could have done is log, okay? Log of prices of -1 divided by log of prices of negative length prices, okay? And then no more -1. Okay, so that will be the same. Now, if you recall, if you get the log of a quotient, so this is log of P sub t, price at time t, over price at time t minus 1. The log of this class is actually equal to the log of your numerator minus the log of your denominator. Okay, so log of P sub t over P sub t minus 1 is equal to log of your numerator minus the log of the denominator. Now, if you notice, class, you're getting, what you're doing here is getting the difference, right? So in R, it will be getting the log. Okay. Log of what? You get first the log of each of the elements of your data. Okay. Log at price t, log of p sub t, log of p sub t minus 1, log of p sub t minus 2. You get all the logs first. Okay. The log of the prices. And then once you get the log of the prices, you get the difference. The difference function in R will get the difference. Okay, suppose you have this data, 10, 11, 11, 12, and then 10, and then 9. Suppose you have this data. There's a function in R called difference, diff. And what it does is get the difference of the later value minus the earlier value. So let's suppose this is the latest date, latest price, let's say yesterday, today, and this is the price yesterday, 2 days ago. To get the difference, class, the difference will get the latest minus the earliest. So 11 minus 10, that's 1. 11 minus 11, 0. 12 minus 11, 1. 10 minus 12, negative 2. 9 minus 10, negative 1. So you now have the difference. And the difference, class, the difference object, will have one less element compared to the original object. Okay, because the first element here does not have a prior value for it to subtract with. Okay, so just like the returns class, di ba? Pag returns, if you have 10 data sets, yung returns object magiging 9 na lang. Same thing class with with difference. Okay, if you have 1, 2, 3, 4, 5, 6, 6 prices here, when you get the difference, it will only result in 5 elements. Okay, mababawasan ng isa. Okay, so let me now go to the R code for that. Okay, take a look at this class. So here we're creating the object log returns. And log returns will be, take note, diff log prices. Okay, let's just quickly disentangle this. So you have prices, right? 12 elements here. Now getting the log class, the log of prices, okay, will mean, what will that mean, class? Okay, let me print prices. Prices. I'm sorry, prices. Okay, these are prices, right? 12 objects, 12 observations all in all. When you get the log of this, there will still be 12 elements because it will just be the log. Okay, let me print class log prices. I'll put it in parentheses so that it will be printed immediately. Log of prices goes there. There you go. So that's log of 100, log of 102, log of 103, etc. So there are still 12. There are still 12 elements here, right? Still 12 elements, log of prices. All right? So log prices class will have 12 elements. And then here we get the diff. So when you get the difference in class, we do this, right? The later minus the previous. So 4.62 minus this one, 4.63 minus this one, until 4.67 minus this one. Now there will be only 11 elements. Why? Because the first one does not have a prior value. So if I get this one class diff of the log of prices, what's happening here is that, of course, it will start with prices, this one. And then it will get its log. This is the log, still 12, and then get the difference. Okay, so there will be only 11 elements. Control Enter. Okay, take a look at that class. So let's check. This one, Control C, Control V, minus this one. Control C, Control V. 0.198. There you go. All right. So let me pause again for a while and ask your feedback class. Let's do this first, class. Let's run this first. So one way to get the log returns is just get the log of the prices and then get the difference. Okay, based on the definition of log of a quotient. Okay, let's run this. So you now have log returns here. Okay, andito na yung log returns natin, di ba? Yan ang class, 0.198, 0.9756, ito. No? Naka round off. Okay, so and then once again, ito palitan ulit natin to. Let's make it period period ng from 1 up to the length of ano kanina, may log returns na tayo diba dito kanina? Wala pa pala. Yung ano lang, simple prices. Kung ilan yung simple returns pala. Simple returns. There. 11 din yan, di ba? Okay? And then, all right. Run this, Control Enter. So there you go, class. You now have your 11 periods and then the corresponding log return. Okay, pause again, class. Pause again, allow you to catch up. Okay, I'll post there's the code. No? And when you're done, class, kindly again requesting for your feedback. Thank you, Rick. Laila, thank you. Okay, good. Right. I hope everyone is following along. Okay, I hope you're getting the lesson. Okay, let's continue, class. Okay, so what we have done so far was just to get the compute for the single period. We got the log return for period 1, period 2, period 3. We got the simple return for period 1, period 2, period 3. Let's now cumulate. Let's now get the multi-period returns. So we know, class, that for simple returns, okay, simple returns, we know that the cumulative return will be 1 plus the return at period 1 times 1 plus the return at period 2, etc. until 1 times the return at period 11, okay, and then minus 1. Okay, so that's the formula for multi-period. We cumulate, okay, we add by multiplying. That's a formula. So let's create this object called cumulative simple return, and it will simply be 1. Okay, it's the product, right, class? Product of what? 1 plus. Okay, what are the period returns? The simple returns, class. This one. These are our simple returns, right? So we just get the product, 1 plus all the simple returns, and these are 11, right? So what will happen is that it will first 1 plus the first simple return times 1 plus the second simple returns, because this is product. It will multiply 1 plus simple return 1, then times 1 plus simple return at period 2, etc. And then -1. So it's a pretty straightforward class, pretty straightforward formula. And by the way, class, okay, I'm here, class, this one, cat, no? Cat is concatenate, okay? You use this when you're combining text and perhaps numbers or text with text. So if you take a look at this class, cat, it means concatenate. What are we concatenating? So here we go. First is this text, cumulative simple return. Let's make this period 1 to period 12, period 11, I mean, since there are 11 periods, colon, close, and then comma, okay, comma. So you'll have a colon here, and then the next one will be round what? This one, because we're going to compute this, cumulative simple return, okay? Since you're going to get a decimal here, and then times 100%, 2 decimal places, okay? And that will be the end, class. End of our concatenation. /n means that's the end, okay? All right, so I'll give you a few seconds to run this. I already gave you, class, the, I gave this, no? The description. You'll just have to write the code for us to save on time. I'm going to run this, and then take a look here. Cumulative simple return, period 1 to period 11, colon, okay, that one, and then here, class. So it will be 7%. If I add here 4 decimal places, okay, still 7. Kasi 0 naman lahat yung iba. Okay, so what does this tell us? The cumulative return from period 1 to period 11 is 7%. Okay? What you have here are daily returns. 7% is the total return, cumulative returns from period 1 up to period 11. Okay? All right. Once again, class, please chat if you're getting it. Okay, thank you, Jason. Laila, thank you. Kent, thank you. Okay, good. Dul. Okay, Biggs, thank you. Isabella. Thank you. All right. So I'm happy that some of you are responding. I hope the others are able to follow along. So let's now compute for the, okay, this one, class, we use the product, right? So this time, class, let's compute, class. Okay, let's compute. Okay, let me show you, class. Prices again, prices. All right. So this is our prices, right? From 100 up to 107. Now, what if we compare? What if the what if we get the returns starting with the first price up to the last price, and then just ignore the intermediate prices, the intermediate returns? So what will happen, class? If you get the price, if you get the returns of the length of the prices, and then divided by the price at time 1, and then -1, which is what's happening here. We're verifying and getting the returns start and end prices. So that's 107 and 100. So what's the formula here? You know this, class? We're creating this object, actual simple returns. Okay. And then, so let's change the formula. It's the price at day 12. That's the length of prices. Okay. And then this should be divided by the prices at time 1. And then let's change the formula because that's the long cut, minus 1. Okay. So this is it, class. First, prices. We're getting the price. Length of prices is 12. So that means get the price at day 12. Then divide it by the prices at day 1, which is 100. Okay, so that's 107 divided by 100, and then subtract 1. Okay, and then let's get the actual simple returns from uh, the price at day 12 to the price at day 1. Okay, and then concatenate this with the actual simple return, which is this one. So this one, just like above, we're concatenating text and actual. This is a value, right? Because this is a computation. Times 102. Okay. So let's run this. There you go, class. So it's the same, class. It's the same. So we were able to verify that indeed, if we're going to get the simple returns daily and then adding it, it's the same as just getting the last price, then compare it with the first price, and then get the returns. So it's still 7%. Okay, I hope that's clear, class. So let's, any questions about this? About the actual? So the actual is just comparing the latest price and the earliest price. And you get the same, class. You get the same as cumulating, getting the formula 1 plus the product of 1 plus the simple return per period. All right, then we also, class, get the cumulative log return using the sum. A while ago, what we did was to get the diff log, right? This time, we just sum up the log returns because we already have the log returns, right? The log returns are this one. Let me just log returns. Ba ito class yung diff log natin kanina, ito, no? These are your log returns. And then let's just get the sum of all this. Sum log returns, and then we get the cumulative, no? Here. Let's run this. Okay, and the log returns is maybe let's multiply this by 100 times 100. Okay, so it's 6.7659%. Okay, as compared to your 7% for your simple returns. And that verifies that indeed your simple returns will be greater than your log returns. Okay, and then this is another formula. We just sum this up. And then this one, ito class yung getting the log of the prices, okay, divided by the price at time. Kino-compare din natin, class, dito yung price at time 12 divided by the price at time 1. And let's see if it will be the same. Okay, times, let's make this, let's convert the decimal. So ito lang yung class, no? It will be simply the price at time 12, ito yun, 107, divided by the price at time 1. So ito class yung sinasubset natin. Specifically, isa lang yan. Ha? Length of prices is 12. So it will just get the 12th price. Length at prices at 1, the first one. So it will be the log of this one divided by this one. Okay? And then we just create a text out of it. There you go. Actual log returns, which is the log of a price at day 12 divided by price at day 1 is 6.7659%. Okay? And then we convert class. If we have this 6.7659, that's our actual log return, or that's also our cumulative log return, the same thing. Let's try to check if we convert it to simple. So simple from log is exponential of your cumulative log returns until z minus 1. Okay, maybe I'll just share this with you to save on time. Most anyway, I did not share with you. Okay, you can just use this class, the last one. And then kindly tell me, class, if what you get here is exponential ng cumulative log returns, which is supposed to convert your log returns into simple returns. What are you getting? I'm expecting 7% class. And I leave as an exercise for you, converting the cumulative simple returns into log returns. Okay, are you getting 7% class? Yeah, good. Thank you. Thank you, Laila. Thank you, Rick. Okay, Laila and Rick got 7%. How about the others, class? You're correct. We're expecting 7%. Okay. Thank you, Kent. Thank you. Abdul, thank you. Great. Jason, Pablo, thank you. All right. I leave you to you as an exercise class, converting this time yung cumulative log returns into cumulative cumulative simple returns into log returns. Okay, which is supposed to be 1 plus r sub t, right? And then plus 1. Sorry, 1 plus, r sub t, log of that, no, sorry. Log of that, walang plus 1. 1 plus r sub t. Okay, lagay ko na lang dito, no? From log from simple. Ginawa ko ba sa ilalim yan? Hindi. Okay. So it will be log, right? Log of 1 plus cumulative, ano natin? Simple return. There. Okay. And then just use this Control C, Control V. This is log return derived from cumulative simple return. So this would be log from simple. Control C, Control V, 4 decimal places. All right, and then I'll run this, Control Enter. There, class, 6.5468. Ba't mag-iba? Mali ito. 1 plus, dapat, not, simple. There you go, 7659. Okay, thank you so much, class. So far clear? Kindly chat, please. Control C. Right, good. Thank you so much. All right. So we leave this class, we leave this manual computation. At least let me have a very quick review. We learned how to compute for the simple return for a single period. We learned to cumulate simple returns, okay, using the formula uh, R sub t is equal to the product class from I is equal to period 1 up to period n of the product of 1 plus your R sub I, okay, and then minus 1. We also learned how to compute for the log returns of a single period and the log returns of a multi-period. We say that in finance, using log returns is better compared to just using simple returns, okay? And then we learned also how to convert from log to simple and then from simple to log. And we also, by way of review, remember that if the returns are very small, lower than, let's say, 5%, then the log returns and the simple returns will tend to be approximately the same, okay, for very small returns. Okay, we now go to, this is the real stuff now. We're going to use Quantmod and Performance Analytics, very important packages in R. So if you haven't loaded that, let's first make sure that the Pacman package, I think we learned this last time, Pacman class, make sure that Pacman is loaded. If you haven't installed Pacman, please install that now. So you know how to do it, install, and then write Pacman, okay? And then include install dependencies and then install. Okay, I'll give you a few seconds, class. And once you have installed Pacman, please inform me about it, that Pacman is already installed. Okay, and if you have already installed it in the past, okay, we can make use of it here, Pacman, and then the double colon here signifies that whatever function we're using comes from the Pacman package. So let's see, p underscore load. There's a function here called p load. There you go, here. P underscore load, tab, okay, and then Quantmod, and then Performance Analytics. There you go. Okay. Okay, this one is easier, class, because it will automatically install and then require at the same time. So if you haven't loaded Quantmod, load first Pacman, and then once you have loaded Pacman, make sure you require it. Then you run this. It will automatically install Quantmod and Performance Analytics at the same time, and then it will also require it. So no need to type library. Okay, so once you have done this, class, once you have installed and loaded both the packages, class, kindly please chat in the chat box. Okay, thank you, Rick. Thank you, Laila. Okay, let's wait for the others. Pablo, thank you. I noticed that I keep on seeing the same names. I hope everyone is also following along. Natalie, thank you. Kent, Jose, thank you. Juan, thank you. Isabel. Okay, Wei Hong, thank you. Alden, thank you. All right. So, okay, let's now, class, make use of Quantmod, a very powerful package. Quantmod, let's first take a look at here, class, under packages. Tingnan muna natin, class. Okay, konti na lang time, pero this is important. Type Quantmod. Di ko pa pala nala library. Okay, let me run this also. Okay. Packages, Quantmod, make sure it's checked. And then let's click this class. So this is quantitative financial modeling framework. Okay, you can learn more about this by going to the description here. Description. So this was authored by Jeffrey Ryan together with Ulrich Smith. These are who's who as far as packages in financial analytics is concerned. You can check class the URL from where it came from, okay, and learn more about it by the documentation. Where's the documentation? But let me go back, class, and go back, and let's take a look at this one. These are the functions that are available in Quantmod. A lot of functions, class. Okay, this is used for technical trading, for stock analysis, investment analysis, and the function that we're going to use now is Quantmod here. Quantmod. If I click this, class, okay, so this is from Quantmod is from the Quantmod package, and this, okay, mali. Sorry. Uh, what I wanted is get symbols, class, here. The function get symbols here. Get symbols, you can see that there are many, class, many types of get symbols. You have get symbols, Alpha Vantage, Bloomberg, CSV, Fred, MySQL, okay, Wanda, may Wanda dito, meron pa. Yahoo, okay, etc. So what we're going to use is the generic get symbols. If I click this, so this is the syntax, get symbols, and then we have here some parameters, source, etc. Okay, we're going to use this and I'm going to discuss how this is used. Okay, so let's begin here, class. We use a function get symbols. And then you first have to know what the ticker symbol of the asset you'd like to download. Unfortunately, class, mada-download lang natin are prices that are recorded in Yahoo Finance, in Nasdaq, in Yahoo Finance mostly. And Philippine stocks are not recorded there. So hindi tayo makakakuha ng Philippine stocks doon. Okay? So we have Apple and then source is equal to Yahoo. This is the default. If you don't specify this, then automatically R will get it from Yahoo. And then we can specify the date. Okay? So from what to what? So from 2020, January 1, 2020, up to 2024, 12/31. And then we have here auto.assign is equal to true. This auto.assign is equal to true, class, means that R will create an object out of this, and it will give a name to the object, the same name as the ticker symbol. AAPL is the ID of Apple in the stock market. Okay? All right, so let's run this, class, and see what happens. Get symbols, Control Enter. And when you run this, you'll see that an object called AAPL is created because here auto.assign is equal to true, which means that the object that you're creating is Apple. If you don't want it to be named as Apple, let's just do this, okay? So I'm going to create now maybe small AAPL, alt minus. So take a look at this one, class. I'm going to create an object called small AAPL. Same thing, get symbols, source is equal to Yahoo, same dates. And then I have to put here auto.assign is equal to false, which means I will not let R give a name to the object that I'm creating, similar to capital AAPL. So let's run this and see what happens. Control Enter. And then you can see here that there's this object, small AAPL. It's exactly the same as the big AAPL, only that they have different names. If I click this, so what's inside this object AAPL? You have OHLC, open, high, low, close, volume adjusted. These are the stock prices of Apple from January 2. We said January 1, but there was no trading on January 1, so our Yahoo gave us from January 2. And then until Okay, December 30, 2024. We said December 31, but there was no trading on December 31. So it gave us only December 30. All right, so you have the stock prices complete. So that's how important this package is, because it allows us to get data directly into R. From Yahoo, from Fred, we're going to look at this other data in the next days. And then Apple has 6 columns: opening price, highest, lowest, closing, volume, and adjusted. If you want to get just one, for example, this one, Apple adjusted, okay? So let's create this object, Apple adjusted close, okay? And I can use the big one, class, or the small letter, it's the same, Apple, and then dollar, Apple dot adjusted. Okay, so this will create now an object with only one column. Okay, it's almost time, class. I'll end in this. Okay, Control Enter. All right, and then check natin, Apple adjusted close. There you go. Isa lang, no? Adjusted price. And then, if you need to go, class, please, I'll just record this, yung huli, yung returns na to, no? Okay, so we can compute for the returns. Madali ito, class, kaysa dun sa kanina, no? So, Apple simple returns using Quantmod. So, there's a function called daily return. Okay, daily return. And then we get the daily return of the object Apple adjusted close. Okay, so let's run this, Control Enter. So we have now this object, Apple simple returns Quantmod. Okay, ito siya, no? Notice the first element here, January 2, is 00000. Okay, why? Because it has no prior value. Kaya zinero out ni. We'll discuss this next meeting. And then I don't like the column name daily.returns. I'm just going to change it into, okay, column names, yung Apple simple returns, let's make it IAPL, Apple AAPL dot simple returns. Okay, that simple dot return. Okay, and then if we run this, Control Enter, the column name was changed. Okay. All right. So thank you very much, class. Let me end recording.